Aloha, Richard Halverson here. This is ITS148, and today is November 23rd. Let me share my screen.
I don't know. What would you think? I don't know.
And here we are. Let's see. We are in the last 3 weeks of the course. We're still studying inheritance. So I'm going to finish up the labs in chapter 14. Just to confirm how far we got last time, let me check. And looks like we got to 14.9 was the last lab we did. So let's see if there's a 14.10. And here we are. Okay. Let's see. Let me look in here. Okay, so in this, still trying to open up my notes here. 14. It's such a big job. 10. Okay. Given the base class of book, okay, so we have a class called book, and then we're going to define a derived class from book called encyclopedia. So within this derived encyclopedia class, we're going to define a print, and which is going to override the book class's print. Okay, so we're going to create a class, a derived class from the book class. The book class has its own print info, but we're going to override that with our own print info. So that's what's going on here. And the way we're going to edit it is we're going to print out the title, the author, the publisher, publication date, and so on. Also, we're going to add the edition and the number of volumes. Okay, so what we're going to do is this is input, the name of the book, the name of the author, let me just. All right, so this is a canned program we've set up here. Let's take a look and see what it does. We're gonna it asks for these inputs. We're gonna create a book. Where is this? We're gonna get some inputs. First thing we're gonna do is we're gonna create an instance of a book using the book class, print that out, and then we're gonna create an instance of an encyclopedia, which is the class that we're gonna write that is derived from the book class. Okay, so let's I'm gonna open up a replit here, replit.com. And the advantage, of course, of replit.com is that anybody can go in and see my REPLs. So ITS148, and I'm going to create a new one. I've got 14.7, 8, and 9 here that you can go look at. You just have to go to this URL right here. I can show that to you. You copy this URL, and I'll open up some unknown browser like Opera right here. And if we go to that URL, we have not signed in. Oh, let me do this. Go to first of all, let me create the REPL, and I'm going to name it this thing. I'm going to name it that. Let me copy this over here. It's a Python, and I'm going to name it this. Create the REPL. And what you can do now, let me get this URL correct. This is the URL that you can go to. Let me copy this, and if we go over here and we paste it here, we see that the URL is this replit.com at ITS148, and these are all the I've started these labs for you, and these are created last class. And so right now I'm going to start working on this one here, 14.10.1. And you notice that I have not logged in. I'm able to see my picture is right up here on the video. So I'm going to move this. I have not logged in, but I'm still able to see all of the things that I did that I'm going to do today and last time. And one nice thing about this is, of course, if you look at, for example, what we did last time, you're able to run the program, and you're also able to see the code that it takes to run the program. You can run the program by clicking the run here, but then we also have the code that I wrote. And this was what I wrote last time, gave you some hints and so on. So I just wanted to show you that. Let me just get this out of the way now. All right, so I'm gonna, this is what the input's gonna look like, and I'm just gonna make it easier for everybody, and I'm gonna copy this, copy, and I'm gonna paste it over into the REPL here as a comment. Enter, paste, there we go. And a couple more of these. All right, so this is a huge comment. I'm going to drag this over here, explaining what it's supposed to do. And then I'm also going to copy this code here. Paste it down here. Oh, can I paste? I'm just going to do Control V. Does that work? Oh yeah, okay. So we see that this is the reason there's a squiggly line there is because this is the class we need to fill in. And so there's these inputs here, and I'm just going to make it a little bit easier for myself. And I'm going to say what to type in here. No, in fact, I'm not going to do that. I am going to set these values directly. I'm not going to mess with this. I'm going to say title equals I'm going to make it easier for myself. I'm going to say the title equals this stuff here. So I'm just going to make it put this up here, and that way I don't have to enter in data all the time as I'm debugging this thing. So let's find all of this here. And the first input is going to be the Hobbit. Copy, paste. And the second is going to be J.R.R. Tolkien. I'm doing this because I don't want to have to type in the data all the time when I'm debugging this. So I'm just making this easier for me here now. It's kind of a waste of time. Actually, I'm kind of wasting your time. Publication date is this. And then there's this title of this encyclopedia here. And then there's the looks like the author of the encyclopedia. By the way, you're not going to do this when you enter the program. I hope it's clear why I'm doing this. Publication date 2001. The only reason I'm doing this is so when I run this thing, I don't have to always type in all this information over and over again. And this is just going to be a 1. Okay. All right. So this is my, so I've set it up and all the inputs are there. And now what happens if I run it? I'm going to try, oh, there's an error here. So I'm just going to say, pass. So there's no error. Okay, the first one should work. Let's see. Okay, the first one worked. Book information. That's because this was able to work and this was able to work. But when it came to here, it tried to create this new instance of this class, which has not been defined yet, you see. So we have to define the class. And then this should work done. So let's see what we got here. Okay, so the first thing I got to do is, since this encyclopedia is derived from book, I first need to define the init and the init when you define it's the constructor. I'm defining, this is the constructor. So I'm defining the constructor right now. And that's going to have a self. And it's going to have a title. It's going to have all the things that that the encyclopedia should have. So not only this stuff, which is in a book, but these two additional attributes. So I tell you what, I'm going to make my life easier, and I'm just going to copy this, copy, and I'm going to paste it right here. No paste, okay. Control V, Control Shift V. I must not copy this. Copy, paste. Don't need that last comma. Okay, so this is the init. Now, what do I do with this? Well, the first thing I do is I need to take this part, this first part, and it's got to be a colon here, and invoke the constructor for the book class. So I'm going to say book dot init of these things up to here. Copy. Paste, okay. Paste, Control V, there we go. So this creates the instance of the book class, and then I need to, then there's two more, there's this and this. See, these four are going to be taken care of up here, those four. But I got two more here, which I got to take care of. And so I'm going to say self dot addition is equal to this addition. So addition, it's kind of confusing that the names are the same, but, and then self dot num volumes equals this num volumes. Copy, does this work? Is there a paste? No. Control V. Okay, so that that takes care of the constructor part of encyclopedia. So we're done with this. Next, I got to do, so I've done this part, and now I got to do the print thing. So I'm going to say define a new print info of self. And so now this print info is going to override this print info. I'm going to want all of this in there. So I'm just going to copy this. Copy. And I'm going to paste it like right here. Let's see, how do I make this better? I'm going to grab all of this and go back one. Yeah, okay, I can line that up there. All right, so that prints out the publication. How is this supposed to print out? It's supposed to print out the encyclopedia, the author, the publisher, the publication date, same as up here. And all we got to do is add the 2 down at the bottom. So you need to add the print statements for down at the bottom here. I think that's all you have to do. What happens if we run this? Is that this? Try again. Error. Sometimes it takes a while, and now it's connected. Okay, now when we run it, all right, so we print this book information. Let me make this wider. So it looks almost correct. This part is correct. And this part is correct down to here, and you just have to finish it. All right. Very good. What's next? Okay, so the point of this assignment, of this lab, was to demonstrate that you know how to create a derived class, create a subclass from a class. So it is this, defining encyclopedia from book is what you're supposed to do here. All right, so what's next? Let's do this plant information. Given a plant, given a base plant and a derived, so we're gonna have a base class called plant, and then we're gonna create a derived class called flower. And so we're supposed to write a program to create a list called my garden and store the objects that belong to the plant class or the flower class in the list. And then we're going to create a function called print list that uses the print info instance methods defined in the respective classes and prints each element in my garden. So my garden is a list. The program should read the plants or flowers from the input, ending with a -1, add each plant or flower to the my garden list, and then at the end, it's going to output the list. All right. So let's take a look at what the code looks like that they give us. I'm going to create another REPL here. Let me go back to here and back to teams and 148. And I'm going to create a new team REPL. And it's going to be a Python replet. And I'm going to name it this. All righty. So first thing I'm going to do is I think I'll just copy this part over. Copy. I'm going to paste it here. All right. So we've got a plant and it prints that. We've got a flower. It derived from plant. And we've added this is annual and the color of the flowers. And here's the print info for a flower. And what we want to do is you want to define a print list function that prints a list of the objects in the list. So first we got to, that can hold object of plant objects of type plant. So let me see what my notes say. All right, so the first thing we got to do is we got to create a list, create a list object here, right here. So I'm going to say, well, I guess we're indenting twice in here. I guess we're indenting twice. Let's not indent twice. Let's just indent once. This doesn't matter. Just have to be consistent with the indentation. So the first indent is this along with this. And I'm going to create a new list called My Garden. And I can just go like this. There we go. And this is going to input a string. Let's see what this is supposed to do. Okay, so the input is going to be, first it's going to say what the type is, and then it's going to say what the name is, and then I presume it's going to say some information about it. This is the name and the cost, and for a flower, it's going to be this specifies that it's going to be a flower type, and then there's the name and the cost. And whether or not it's annual, false, true or false. Yes. And this is the color of this plant. So here we're actually reading in 4 plants, and the middle 2 are actually flowers. So in the and -1 says we're at the end. So this is so we're going to read in the user string, and that would be, I might as well put this up here. This is what the input's going to look like. I'm going to put it as a comment up at the top here. Okay, so the input is while the user string is not equal to -1, we have to first we're going to read in to see if it is a so we have the input string. The first one is going to look like this whole thing. So we're going to need to split it. Check if this. Okay, I'm just going to go. I might as well just start right here. And so what should I call it? Tokens. It seems to be a popular word. Tokens equals user string split. And now I've got each of these. I'm going to copy this, put it down below. I want to put it down here. So now I've got these tokens, and I want to check the first token to see if it's a plant. So if tokens of 0, which is the first one, is equal to plant, this one here is equal to plant, then we have plants. So we want to say that what are the plant name and plant cost? So we want to say Oh, we have to create a new instance of the plant. I'm going to say well, okay, I guess I should do this. The name is going to be equal to tokens. The name of the plant is going to be equal to tokens1, and the that's this Spirea, a mouse, and the cost is this. So the cost is 2 tokens 2, and now I can create an instance of it, and I can say my plant or something equals plant of name and cost. See, when you create, I'm creating an instance of a plant, and we need to pass it 2 arguments: the name of the plant and the cost, and that comes in here. So this is token 0, this is token 1, this is token 2. Okay, so and then once we're done with that, we can add my plant to the list. Yeah, to the list, which is my garden. So I can say my garden dot append plant. I guess no, my plant. And then we've done that, and then we're going to read a new string. So we're going to go on and read this one next. Oh, wait a second. I got to take care of the case of if it's a flower. So if tokens of 0 is a plant, then we do this. Otherwise, tokens of 0 is equal to flower. Then we're going to do all this. Copy. We're going to do all this. But we need but we're going to grab this and this also. So let me grab that, and that's going to be, what is the third one? Type. Type. Is that what it's called? Oh, whether it's annual or not. What do I call it over here? Is annual. Well, I'm just going to call it is annual, I guess. I like that better than type. Is annual is equal to tokens 3 and color is equal to tokens 4. And then I can call it my plant again, doesn't matter. I'm going to call it but it's in its flower. And it's got to be name, cost, is annual, and color. This, yeah, okay, so flower is this. All right. So, and then we do this. Yes, okay, that should work. I'm gonna try this. Is there a print function? I gotta write a print function. You have to write a print function. You have to write a function to print the list. How is it supposed to look anyway? Oh, it's supposed to look like this. Well, I'm gonna run this and see what it looks like. Do we ever print anything here? No, I don't think we do. Okay, so you're supposed to write a print function up here. I'm just going to print it all down here, and I'll leave the making it a function up to you. Okay, so right down here, I'm going to say, I'll be done. So I'm going to do for plant in my plants. Oh, my garden. In my garden. For plant in my garden. Plant print info. Okay, so this is just going to print. This should print them down at the bottom. Okay, and what you're supposed to do is instead of writing it directly like that, you're supposed to write a function up here, and then you call the function. Okay, that's all. You might probably pass the list to the function too, or not. Yeah, you pass the list to the function, and the function prints it. So anyway, so let's run this and see what it looks like. Okay, let's do this. Run. Now you get this thing to start up again. Refresh this or something. What does this do? Start, run. Here we go, working. Okay, connected. Oh, is it asking? Is it running? All right, I gotta, where are we asking for stuff? Enter string. I gotta put a thing there. Enter string. I gotta have some kind of prompt. Let me know. Okay, start this again. Okay, there we go. So I'm gonna enter plant, Spira, S-P-I-R-E-A, whatever that is, and a 10. And I'm gonna enter another one. I'm gonna say flower, rose, whatever 30 means, whatever that means, and red, I don't know. And then I'm gonna do a -1, -1. And it prints out the plant information and it prints out the flower information, and see it actually printed out 4 things instead of 2 things. All right, so this is enough for you. You just need to add the print list function. All righty, it's 12:09. What's next? Are we done with? We're done with chapter 14. All right, recursive functions. A function may call other functions, including itself. The function that calls itself is called a recursive function. So you should read this and go through this and to try to wrap your head around the concept of a recursive function. It's not that difficult. So let's just do some of these activities here. Recursive functions. How many times is countdown called if the strip calls countdown 5? Okay, so this is a method here, and it's we count down 2, and the way this method works is this calls this, and it's got a number here. The number's 2 to start out with, and so the first thing it does is it checks to see if the count is 0, and if it's not 0, it goes to the else, and if it prints what the count is, but then it calls itself again with 1 minus the count. So the first time this runs, this is a 2. It comes to here, it prints the 2, and then it calls itself again with 1, because 2 minus 1 is 1, comes back around, it starts up again. This is a 1. This skips this, comes down to here. It's going to print the 1, calls itself again. Now 1 minus 1 is 0. So it calls itself with 0, comes back in here, countdown of 0, count is equal to 0. So it prints go. When it's done printing go, it returns. And it returns to this point right here, because that's where that's the point. That's where it called this. Okay, so now count is equal to 0, right? So this is where it called calling countdown with a 0 there, right here. And so the method is done. It returns back up to where it was called, which is here. It ends up returning here 3 times, because once it hits go, then and count is equal to 0, then it starts to return and everything is done. So it's done, it's done, it's done. And then we end up printing out something that looks like this. Let's just run this and see what it looks like. First that runs, calls that's equal to that. It skips that, it prints the 2, okay? And now it's going to call itself again. And calls itself with 1, skips out, prints the count. That's where the 1 comes in. It's about to call itself again with 0. So it comes up here. And now this is taken, so it prints go. And we're done, because once this function is done, once it returns from here, then we're done. And when we're done, we return. So at the end, we're just gonna return, 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 return. So there's gonna be like 3 returns in a row. I will illustrate this sometime today when I get a chance to, but let's move on right now just to see if we understand this part. How many times is countdown called if the script calls 5? Well, when we call it, when it's 2, it looks like it's called 3 times. Yeah. So if it's 5, it must be 6. One more. 5, 4, 3, 2, 1, 0. That's 6. Okay. The first call is 5, and then it calls itself with 4, then 3, then 2, then 1, then 0, and then it's the last instance does not call again, but instead it returns. So returns, 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 returns. I'm gonna do a quick little. Time is it 12:13? How many recursive problems do we have in this one? Oh, we got a few. Okay, so we're gonna go on to the next time, probably. So let me just I would like to copy this program here, and I'm gonna just do a couple things to make it easier to see if we understand. Let me go make a REPL, and this is gonna be a and I'm going to call it this. Copy, paste. And I'm going to copy the program here. Copy. And I'm going to paste it here. Now, what I'm going to do is right here, I'm going to say print return, okay, return from count of count minus 1. I'm going to do this. Okay, so all I'm doing here is we should see the same thing that we saw here, except for we're going to see it. So we're going to see this last thing where it's done. In fact, I'm going to change it a little bit. I'm going to say, I'm going to do this. I'm going to say this instead. I'm not going to put that there. I'm going to put, when this function is done, it's right here. This is where I'm going to print. See, I'm going to back these up a little bit because I don't like it. Okay, oops. I'm going to say this. Okay, so it does this. If it's 0, it prints go. Otherwise, it calls itself again. And when it's all done with both of these things, I'm going to say return. Oops. Return from countdown of count. Okay, so this is going to say it's going to return from this. Okay, so it tells you when it's done. And then the first thing we're going to do is let's call this count 2. So let's see what happens when we run here. Okay, so it prints out the 2. It prints out, what is it? Prints out the 2. It prints out the 1. It prints out the go. And then it's going to return from 0 and it's going to return from 1 and return from 2. So you see it prints 2, and then here it comes back around and prints 1, and here it comes back around, and because count is 0, it prints go. And then when this is done, it returns from count of 0. And when that returns, it's done with this, and it's going to come back and it's returned from count 1, and it's going to return from count 2. So you need to get used to sort of get this in your head that this is like the unstacking of the recursive algorithm. You see, it starts with 2, and then it calls itself again with 1, calls itself again with 0, and then it's done as it returns. It's got to return back to where it came from. So it returns to the 1, and then it returns to the 2, and then it's done. See, so this is actually what goes on here. Now here you can we'll learn that this is there's here we do something, and then we return, and the call is calling itself, and it may be there's times when we do recursion where we do the call first, and then after we return, we do the function that we're going to do. So in this case, we are doing as we are recursively executing the program, it does something, and then it calls itself, and then it comes back around, and it does something, then it calls itself. And there's got to be a point where it's not going to call itself anymore. So something has got to change each time, just like in a while loop. Something's got to change each time. So sooner or later, we're going to hit this terminating condition, and it's usually something like this, where we've reached the end, and then we're done, and then we return, and then we end up unraveling the stack as we return down the line, and we end up back here again. So we can do something like print done. See, done. All right. So anyway, I just wanted to point that out. Let's do one of these. Let's go and do the lab, and then we can come back and cover some more of this stuff. So I'd like to get started with some of these already. Okay, write a program that lists all the ways people can line up for a photo, all permutations of a list of strings. The program will read a list of one word names, then use a recursive method to create and output all possible orderings of those names, one ordering per line. So it's going to read something like this. It reads these three names, and then it's going to print out all commutations, all combinations of these three names, the order. So this is the beginning, and then we're gonna looks like we flipped these two, and then well, anyway, let's let me see what my notes say on this one. I'm gonna set this one aside. I'm gonna go back and cover some more of the because even this first problem here, we need to at least understand how to debug recursion before we can write a recursive program. So let me just continue on with this section here on recursion, and next video we'll start with the labs down here. So we're covering recursive functions here, and you should go through these to make sure you sort of get it in your head how that works. Write a statement that calls a recursive function backwards alphabet with a starting input starting letter. So we're going to start with the letter F, for example, and then it's just going to print the alphabet backwards. And so this is the challenge activity. So this is a function. This is the function. So we're going to count down to A. When we've reached A, we're done. If we have not reached A yet, if the current letter is not A, then we're going to print the letter, and then we're going to figure out what the letter is just before the letter we just printed, and then we're going to call the same method again with this new letter, which is one less, which is the letter before the letter we just printed. And so this will get us the current letter. This gives us the ordinal value of the current letter. And what's the ordinal value? Well, you can search for ASCII table, and we can look at an ASCII table. Any one of these ASCII tables will work. What does this one look like? Here's one, ASCII table. So if we're printing out the letter A, F is going to be decimal 102. And so that's the ordinal value. The ordinal value of F is 102 in decimal. And then we subtract 1 from the ordinal value, it's going to be 100, and that's going to be 101, E, D, C, B, and A. So that's what this ordinal value is, just so you know. And so that's what this does, finds the ordinal value of the current character, subtracts 1 from it, and then finds the character for that ordinal value. So if the current letter is F, then the ordinal value of F is 102. Subtract 1 from 102, we get 101. And what's the character for 101? And that's E. And so this kind of works there. So what's our solution? It would be backwards alphabet of starting letter. So I think this is all we got to do because if we run this, I'm going to go back over to my REPL here, and I'm going to do another one here. I'm just going to comment this out. And so now we're doing this, and it's going to ask for an input, starting letter. I'm just going to put that here. And it actually counts down to lowercase a. Well, what happens when I run this? It's going to ask me for a starting letter. I wonder how you get this to restart. Do I have to do Control Enter? Oh. Okay, starting letter. Now, if I put F, it counts down. And so I'm going to do the same thing I did last time. I'm going to say print returning from current letter. So that's just going to print that out. Now, if I run it and I put F, see it counts down, prints these out, and then it starts returning. And it's going to return, you know, the last one it called is going to be the first one that it returns. So this is why we see A, B, C, D, E, F, because this is the order we go down, we go into the stack. You can think of it that way. It's a stack. We travel, we create the stack, it's got that in, and then we have to return back out of the stack, and we return the last one we went in is the first one that comes out, and that's why this ends up looking like this. So really what happens is this thing gets printed for F, E, D, C, and B, and this is where it prints A, and then once it prints A, then this instance is done, and then it returns, and each time it returns, it's going to either return right here, it's going to return when it's done with this, in which case it goes to here, or it's going to return when it comes back from here. Calls itself, and then when it's done, it comes back right at this point, and it's done, so then it prints this again. So that's how that works. All right. So that's that. That's probably what the challenge activity looks. Okay, recursive case searching. So this is the binary search program, and we're section 15.2. I think I'm going to stop here, and next time I'll start up right here at 15.2 on the recursive binary search algorithm. This is something you're probably going to have to learn. And if you ever go on in programming, you should probably kind of commit this algorithm to memory, and something you may always refer back to. It's really an elegant algorithm because if everything is sorted, if you have a sorted list and you want to search, it takes log to the base 2 steps to find the elements. So in other words, if you have a list of 1,000 and it's sorted, it should only take you 10 tries to get to to find out if the element you're looking for is in the list or not. So anyway, that's it for today. I will see you next time. Thanks for watching.